So I'm saying that, okay, let me choose a particular data 1 over 2k. So for a given k, let's choose 1 over 2k and let's make the measure of some set less than what you call 1 over 2k. If this is happening, then the mu of ek must be bigger than or equal to epsilon. Because if the mu of ek is also less than epsilon, then you're assuming what you want to prove. Are you getting the point? So since I'm doing it through contradiction, so I'm gonna say that it's better that not better, but it's going to happen for sure that there are some sets, such kind of a sets, which violate this inequality, which violate this statement. Okay. So I'm finding some EKs for which this is not true. And I'm saying that let's take the union and intersection in this manner of those EKs and give them a name, F factor. And let's think about their measure. Now, what would be the mu of F factor? Let's compute the mu of F. So the mu of F is going to be the mu. So one of the things is that, think about it, it's not going to be k equal to 1, it's going to be k equal to n. That's a mistake that we do all the time. Okay? So it will be k equal to n to infinity. So if I set n to be 1, then this is what? K equal to 1 to infinity. And if n is 2, then it's 2 to infinity. So what's the relationship between k equal to 1 and 2? So it's kind of decreasing actually, decreasing. Because for n equal to 1, you have 1 to infinity whole, everything. And then for n equal to 2, you have 2 to infinity, which is already a subset of previous set. So I can say that this is a decreasing sequence of the set size. So if I take the intersection of the decreasing sequence of set, what would be the mu? So by the continuity property, I can say that this is same as limit n goes to infinity of the mu of the union k equal to n to infinity of ek. But this n is less than or equal to limit n goes to infinity of some k equal to infinity k. But I can say that this is less than or equal to, or mu of ek. This is less than or equal to n goes to infinity of, I should write it directly. Okay. So this is less than or equal to limit n goes to infinity of, from where to where, k equal to n to infinity of 1 over 2 to the k. Okay. What would be this sum? You can compute this as simple geometric sum actually. You can compute it easily. When you compute it and take limit n goes to infinity, you're going to get us it. You will get us it. So the mu of the measure f is equal to 0. Let's compute the nu of the f. Okay. The nu of the f, again by the same property, you're going to get limit n goes to infinity of nu of union of k equal to n to infinity ek. Okay? And I know that mu of ek is bigger than or equal to epsilon. So obviously this is bigger than or equal to epsilon. Again, what does this mean? This means that mu of f is not 0. Means that mu of f is positive. So mu of f is 0, but mu of f is not positive, hence mu is not absolutely continuous with respect to mu. So you're going to say that you got a contradiction. So therefore, you have the result. you have last lemma. Basically, do the theorem in our next discussion. So this is just a characterization of definition of the absolute continuum. You can replace it by definition. That's what is the characterization mean actually. So when you say that okay, you want to characterize something, that means that you want to prove something equivalent to it. That's what characterization means. There's another simple lemma, and this lemma will be useful for our theorem. That mu and nu be finite positive measures. Positive measures. So then, okay, on a same space x comma a, and you have this interesting condition. Either, so any two finite positive measures, for any two positive finite measures, this is true. Either one is similar to other, either mu is similar to other, so this must be true, or there exists an epsilon positive and set G such that mu of G is positive and mu minus epsilon mu is non-negative. Not negative. But a positive is positive. Let's try to make sense of this situation. So if you have two finite positive measures, so for any two given finite positive measures, one of the two possibilities must be true. Number one, either both are mutually singular. If not, then I can find a number and a set, okay, with a positive measure mu, such that if you perturb the nu by this epsilon multiple of mu, this would be still positive. This is what, so simply, so I have a measure nu and I am perturbing it by a small factor of mu and I get still positive. Mu of G is positive and negative. What it means is, इन दोनों के दरमियान, so either mu is similar to mu. Mu similar to mu का मतलब क्या है? So you have sets E and F such that their union is X and their intersection is empty. Then mu of T is 0 and mu of F is what we call zero. This is true. Then we are saying that if this is not true, that they are mutually singular, then what do they say? That we can find a small epsilon, okay, and a set G such that this set G has a positive measure under one measure, which could be nu as well. I mean, you can take nu here instead of mu. It makes no difference. Then you need to take the perturbation of mu minus epsilon. Okay. Looks up pretty strange. Do you understand perturbation? Roughly, what you are saying is that from nu you are subtracting a small chunk of mu, a fraction of mu, and you still get a positive. Bit strange, but it will be useful. We'll need this statement. Okay, to move on. Let's quickly. Alright, so what would be nu minus 1 over n mu actually? Here's the thing. Nu is a measure. Nu is a measure, I have no idea. Okay. So this is a measure. Which what kind of measure is that? It's a signed measure. It's a signed measure because it can have positive and negative values. Because I don't know the relationship between mu and mu. So it's kind of a signed measure.
How do you say this concept part of the local area of this community?
दोनों prove है. We're gonna say either this will be true or this will be true. समझ रहे हो? ठीक है. So I was saying that consider this measure. Consider this measure mu minus 1 over n nu. So it's a signed measure. Indeed, it's a signed measure. By the way, it's a signed measure for each n. So you change n, so it's like it's an n-dependent measure. So it's not just one measure, but it's a sequence of measures actually. Okay? So if it is a signed measure, then I can find a Hahn decomposition of it for this signed measure. So okay, we can find